This video is on the objective multiply a vector by a scalar. All right, now a scalar is just a real number, right? They call it a scalar because it will scale the vector up, making it larger, longer, or scale it down, making it smaller or shorter. And if you multiply by a negative number, it'll just change the direction completely, give you a vector that points in the opposite direction, as we'll see coming up. Alright, so if you want to see more about the topic, right, click on More Instruction, look at their videos, their notes, their examples. Hopefully those help you. In fact, I'm going to show you some of those notes. So we got multiplying a vector by a scalar. Now we saw, hopefully, adding and subtracting already. While adding and subtracting vectors gives us a new vector with a different magnitude and a different direction, the process of multiplying a vector by a scalar, a constant, right, a scalar is just a number, changes only the magnitude of the vector, or the length of the line. Scalar multiplication has no effect on the direction unless the scalar is negative, in which case the direction of the resulting vector is the opposite of the direction of the original vector. So scalar multiplication is very simple. Just like vector addition was pretty easy, right? You just added corresponding components. Well, when you multiply a vector by a scalar, say the number k, say k times vector v here, you just multiply each component by k. It is that simple. So again, only the length will change unless k is negative, and then the vector reverses direction. And they give you some examples here. All right, if the vector v were the vector 3, 1, 3 times v would have components 9, 3. Right? Half of v would have components 3 halves, 1 half. Negative 1 times v would have components negative 3, negative 1. And here's the drawings, right? If this were v, 3v is just 3 times the length, but pointing in the same direction. Half of v is half the length, pointing in the same direction. Negative 1v is the same length, just pointing in the opposite direction. Okay, and it's really that simple. Alright, so let's take a look at our question. Alright, so the vector u is shown in red. Drag the blue movable point to construct the vector 4 times u. Alright, so notice that u here is a position vector, right? It's starting from the origin. So we could easily write the components of u. In fact, I'll pull up some quick paper here. Hopefully you can see it. There it is. Alright, so vector u here, right, has the components what? It's right 2, down 2. It's positive 2 for the first component, negative 2 for the second component. And they're asking us to construct 4 times u, right? 4 here is called a scalar. Right? Again, very simple. You just multiply the components of u by 4. So the first component would be 2 times 4, 8. The second component would be negative 2 times 4, negative 8. And that's it. And you're going to see that this new vector, 4 times u, it points in the same direction, right, because it's a positive number I multiplied by, but it'll have 4 times the length, right? It'll be 4 times as long. All right, so I'm going to have this new vector for u point to 8, negative 8. So I move this point here over to the point, 8, negative 8. There. And you see it points in the same direction as u, just 4 times the length. Okay. And hopefully that's easy enough. Right? They did the same exact calculation here in the explanation that I showed you on my paper. Alright, that's really it. Now again, if this were a negative number, you'd see that the new vector would point in the opposite direction. That's all. Alright, hopefully watching me do this and reading the more instruction if you need to looking at the answer explanations, reading those, understanding those. I'm hoping all this stuff helps you out when you're working on this material on your own. And thank you very much for watching.